So
Mr.
we are gonna keep explaining the lesson 3 describing the electric circuit. Okay, we started that yesterday our classroom. Today we're gonna continue, but in the beginning we're gonna revise what we explained yesterday or what we just said about the circuits yesterday. So first,
Mister, I'm here.
okay, Nano, go. Okay, so I'm just gonna remove your name later from the.
Yes, me
Okay.
too, because
So
I
guys, you're late. Be careful. You're
Mister, I
supposed
have
to
a
be on
problem
time.
with my laptop.
Okay. So just here again, we said that as we explained yesterday, that any electric circuit at least must have three components, which are the electric power source, okay, or the electric source that could be battery, generator, the electric circuit, or whatever that means, a source of electric charge or a source of electric energy. Then a wire that was going to connect different parts of the circuit together, that the conductor in which the electrons or the current will flow through. And then we have the load that means a device or a tool or whatever the substance, the material that is going to change the electric energy into another form of energy. This load could be a bulb, okay, for example, that will change the electric energy into light energy. It could be a heater that can change the electric energy into heat energy. Can be, for example, a watch or a fan or something like that that will change the electric energy into kinetic energy and so on. So simply here, as we said, that is the components of electric circuit, and this is the battery here concerned as a power source of electric circuit. And as we said, the battery it reacts, or the battery it's that concern the power source in which it generates electricity or electric energy, and that's depend on a chemical reaction that happen between the different components inside the battery, as we said yesterday. So we could find that the battery actually is made up of a zinc case, okay, that represent the negative pole, okay, or represent the negative side of the battery. While here in the middle you can find this graphite rod or carbon rod that represent the positive one. So this positive and this side one, they have a kind of reaction due to an electrolyte, which is a substance that's found in the middle, that is the paste. Okay, so this paste, okay, that allow the reaction and transfer of ions and electrons between the negative and the positive pole. Okay, that's which lead to production of electric energy. After a while, as all the chemical substance inside the battery is gonna completely react, okay, so finally the battery will run out and it will not be able to produce any electric energy. So like here then, guys, we said also yesterday that some electric device designed to transform electric energy, okay, to kinetic energy, like the fan, the watch, okay, toy cars, okay, even cars, okay. And we said that all the chemicals in the battery react, electrons in the battery concentrate at the battery negative terminal, and when the closed circuit is connected, so the electrons start to flow from the negative terminal of the battery toward the positive one. Okay, that means the direction of the current always from the negative pole toward the positive pole. So here we said that all the electric devices or the different loads that found in electric circuit, they are going to change the electric energy into different forms of energy or usable forms of energy, the where that the parts which connect these different types. So here today, that's which we are going to talk about, or that the new part which we are going to explain here, guys. We're going to talk about the series and parallel circuits. We said that whatever the electric circuit is, okay, once the circuit contain more than a load, okay, so we need to connect these loads together, and of course, as Reem said, okay, we connect them by wires, okay. But the question is how we connect them, okay, the way that we connect them by using these wires. So there are two ways, or there are two different types of electric circuit regarding to the way of connection. So we call them series and parallel, okay, circuits. So let's find what are the difference between them. So here, the series circuit, it's an electric circuit with only one path, one route, okay, for the electric current to flow. That means the current just moving in one wire, okay, or that means one loop, okay, or one path that allow electrons to flow in. So in that case here, as they are just has one root or one law, so according to the Ohm's law, when resistance increases, the voltage remains the same, the less current we have. So adding more loads to the same wire, okay, with the same voltage because we have the same power source, so the voltage will not change. That will increase the resistance or the total resistance of this circuit, and that will lead to less current. So let's here take the example to understand it. For example, here guys, we're gonna find that the simple circuit, just one load. Okay, so this 6 volts is gonna create a current in that wire, which is enough to make the light bulbs, okay, or turn on. While once we connect two bulbs here, in that case, okay, they are in series. They are connected in series. Why? Because that's just one path of electrons. Here we have one only path for electrons. So they are connected on the same wire. Could you observe it, guys, here? Guys, is it clear?
Mister, I have a question.
Yes, Fadi.
Yes.
What does it mean to provide two times the two resistance يصير in the two bulbs ولا in the
Yep.
battery overall?
Yes. Let's see here. Here, that means I first need you to configure or to find out what is the series connection. Series connection, that means I'm gonna connect them in the same wire like this. Okay, so that's only one path. We don't have any branches, just the electrons or the electric charge will flow in that way. Yes or no? Is it clear here,
Yes.
guys? Yes. So in that case, once we connect two bulbs in the same wire, we have a constant voltage, which is 6 volts, that the power of the battery. Okay, could become more? No, because the
No.
battery is limited here by 6 volts. So in that case here, let's imagine if the bulb has a resistance equal to ohm. So that means the resistance here, let's get it right here. So let's imagine that the resistance of this bulb is 2 ohm, and here we have this 6 volts. Okay, so that means the current which flow in this wire will be equal, okay, 3 ampere. Yes or no? Because as we know, V equal IR. You get this,
Yes.
guys?
Yes.
Okay. So we get another bulb exactly like this, which have another 2 ohm. So here that's 2 ohm and that's also 2 ohm, and both are connected in the same wire. So overall, the total resistance now is
4.
4. So the total resistance equal 4 ohm. So in that case, if the total resistance is 4 ohm and here we have 6 volts, that will make the current which pass in the wire equal, okay, how much is, okay, 0.75, okay, or
Yes.
just sorry, that's, yep, okay, sorry, no, 1.5, it equal 1.5 ampere. So what's happened to the current here, guys?
The current in one bulb is is way more
The current
than
decreased, the overall current
decrease.
that flow in the circuit decreased. That's why you could see that the bulb is not that bright like this one. It's already light, but it's dim. Why? Because it doesn't get enough energy, because the energy or the current, okay, which is flow in the wire is divided in two bulbs. You get the idea?
Yes.
Is it clear here, guys?
Yes.
Yep. So any other question, guys, or any hard part here?
No, thank you.
Okay, of course, in series connection, as you can see, once a wire get cut or there is a gap in any part of the circuit, a gap here, here, or here, all the loads will turn off. That means all the bulbs will turn off, because that's mean just one path, as we said, for electric charge. So once this path is incomplete, so the electric charge will not flow and the current will stop. So all the loads will stop working. Okay. So like this here, we could say that if we need to mention what is a series connection, we said series connection, it is the connection in which all the loads are going to be connected on the same wire. So we just have one path for electrons or electric charge to flow. And in series connection, the total resistance will be more than okay, or the total resistance will increase, which lead to decrease in the current. Okay. Any hard question here, guys?
No.
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 So let's see here. Okay. The other type of circuit, to find what is the difference here. We said that a parallel circuit, it's an electric circuit which we have more than one path. Okay, that means we have different branches, different wires, okay, in which each load is connected to a separate wire directly to the main source of electricity. Yes, Fadia?
Mister, هو if we have two bulbs and a battery عادي
Yep.
we use one wire or two wire to connect the two bulbs to the battery one or two wires.
We could use the idea, these wires, and we don't care about the number of wires, Fadia. We care about these wires represent just one path or different paths. Let's see here. Watch with me the parallel, and you are gonna find what the difference. Okay.
Okay.
So here in parallel circuit, we said that we have more than one path. Okay. For let's see here, guys, the idea. So we said that in parallel circuit, each device has its own branch or has its own path for electrons. Okay, they are not connected all together. Each load is directly connected to the energy source. Okay, so let's find here that, for example, as we can see here, we have three bulbs. The three bulbs, my question here, as you could observe, the three bulbs are connected together. That means, okay, they connected together by the same wire, or each bulb has its own path of electrons?
No, that's what I'm
Has its
asking
own
about.
path?
Yes, has its own path. So let's back here in series, okay, it's just one wire that connects all of them, okay, one path. You can see that means the electrons only path in this loop. You get this idea? Okay.
Yes.
But here in parallel, okay, it's different. In parallel, each bulb is directly connected to the battery. So like this here, what that means, that once the electron is gonna flow out of the battery, or the current as it's gonna flow from the negative, it's gonna be divided. Some of the current, okay, or the current will pass to this, and another current will pass to this, and another current will pass to this. So each one of these has its own current. They are not sharing the same current. While in series connection, they sharing the same current. That's why when we increase the bulbs, the current decreases, or each bulb receive less amount of current. That's why it appeared dim. While here, the three bulbs, okay, on the same battery, they appear bright because each one is able to pull the complete current it needs from the battery directly. Is it clear here, guys?
Yes.
Yep. So in that situation, or in the parallel circuit, if this wire, for example, is cut, okay, so this bulb only will turn off while the other is still working because they have their own path to the battery. You get the idea, guys? You get this?
Yes.
Yes.
Yep.
Yes.
For example, okay, if this disconnected, so this one only will turn off. Is this and this, okay, disconnected, so these two will turn off, but this one is still working because it has its own path. The only way that I could make the three turn off, that's you disconnect them from the battery. That means removing the source itself. Is it clear here, guys?
Miss, I have a question.
Yes, Fadia.
دلوقتي يا مستر in the third
This one.
the path you mister is not complete.
No, the path is complete. Let's
Yes,
see.
this one.
Let's see. The electron is
لا ما
flowing like
there's a
this.
gap. The اللي هو the
This
top one.
one, this one is a path for that pulp, not that pulp. That means this path for that pulp. So this disconnected, so this pulp turned off. While this one find its own path.
It's still connected to the other bulbs يعني.
No, they are not connected to the other pulps. They are connected to the battery. You get the idea? That means this piece of wire doesn't represent anything here. It's the path for that one. I can draw it by another way to clarify the idea. Look with me. I'm gonna draw it in another way to make it easier for you. Look, Fadia, I'm gonna draw the same. That is the battery. Okay, Fadia?
Yes.
So that is the first path for bulb number one. Okay. I
Okay.
will draw the bulb as a circuit. Okay, as a circle to be easier. Okay.
Okay.
And then that is the second path. Okay, and then that is the third one. You get the idea, Fadia?
Yes.
So
Yes.
if I cut this, these two will keep working. If I cut this, these two will
Yes.
keep working. You get the idea? So each one, it's already connected to the battery. So we don't care about the different branches. You get the idea?
Yes.
Yep. So here like this, guys, that's the idea of the parallel connection, or the parallel. Okay, so in parallel connection, actually here we could find that in that case the current, okay, will not be affected. Okay, the current will not be affected because they are not sharing the same current, but they are sharing the same voltage. You get the idea, guys? You get this?
Yes.
Yep. Yes. So like this here, okay, they have different currents. Each one could get the current it needs, okay, because they are directly connected to the source or to the battery. So any hard question here, guys, till that moment?
No, thank
No. So we just ask a question here, okay? What do you think? What kind of connection found in your homes? Do you connect to the different parts of in your home, okay, in parallel or in series? That means the light bulbs and the different electric devices in your home, they are connected in parallel or in series? Yes, Osama.
In parallel, because when you turn off, for example, one switch, the other keeps and
Yeah, good. Okay, of course they are connected in parallel because as you in your home, once you turn off the light or turn off one switch, okay, the other rooms and the other parts of the home still working. Okay, so they cannot be connected in series because if they are connected in series, once there is a bulb is damaged or unscrewed, the entire home will turn off, and that cannot happen. Yes, okay, so really we use parallel connection as a okay connection in homes, offices, factories, different ways, okay, that to ensure that if there is one part of the circuit is disconnected or is not working, the other parts will keep working and still doing their work without any problem. So here, guys, any other question regarding to this part, guys?
No.
you. No.
So now do we know the difference, okay, between the parallel circuit and the series circuit?
Yes.
Yeah. So we said that electric energy, okay, used in the most homes and businesses is generated at large power plants. That is the power generators, okay, which we have, okay, that mean that power stations which already generate the electricity, okay. And then here we are have a kind of transmission wires, okay, that mean this electricity which is produced in power plants is gonna be passed, okay, or transferred through cables, and these cables of course are moving down the streets here, okay, along the country, and they start to branches into boxes and so on here, okay. So as you could observe here, that's the idea, okay, how the electric energy passes to your home, okay. So we have the main wire, okay, this main wire travel the electric, then this wire, okay, must pass to step down transformer. What is step down transformer? That the transformer that's gonna decrease the voltage. Then, okay, the wire will pass to the electric meter, that one which counts how much okay, electricity you consume per month, okay. And then it passed to the main panel, this main panel that which have the main switches, okay, that control the different, okay, electric routes or electric branches to each room. And as you could see, okay, we have a branch of wire for each room inside your home, okay, which are connected in parallel. Is it clear here, guys?
Mister, I have a question.
Yes, of course.
Mister, هو يعني يعني it's not a question about this one but a previous one.
Yep.
يعني how is our things in our home, يعني the electricity in our home is parallel when يعني there is a switch that can turn off any the all the lights يعني in the house.
Yeah, no, yep, listen. This good question, okay, here it's exactly the same like this here. Okay, the question, there is a switch that could turn all the light of the house while they are powered, because actually this switch it disconnect the source itself. That means disconnect your home from the main wire that comes from the cable outside, like this one here. They are connected in pair, but if I removed the main wire, which is already connected to the battery, the rest will turn off. You got the idea, Hannah Hamdi? So that means,
Yes, thank
yes, in the main panel here, okay, in your home, you may find a switch that could disconnect this main wire, the one you get it already from outside. So once you cut this, all this will turn off because you already removed the source. So you get the idea, Hamdi? Hannah Hamdi, you get the idea?
yes,
Yep.
thank you.
Okay, so like this book, guys, that the part which we're gonna stop at next time. Actually, we're gonna talk about how we could make our home circuit or the circuits in home safe and something like this. So easier part. We're gonna talk about it tomorrow. Okay. So please study this part very well from your textbook, and if there you have any question or something is not clear, okay, you can ask me anytime. Thank you, guys, and goodbye. Do you have any question before end our
هو
meeting,
كده
guys?
ده lesson يا أستاذ؟
What? I can't hear
احنا
you.
كده خلصنا اللسن؟
No, no, no. We still have a little part. We're going to continue tomorrow, inshallah. Okay? Any hard question, guys?
No, thank you.
Thank you, guys. Goodbye.